Hello, I'm Andy McCoy here with Zach, Joel, and Chris, and we are the Quadcopter drone controller group. For this project, we were tasked with creating a new flight controller to replace the CC3D flight controller on the Excite DYS 320 quadcopter. The CC3D is an obsolete controller and lacks functions that even cheap controllers have today. This project was only to design a new and improved flight controller and does not entail any changes to that drone chassis. This project did partner with the CSCE team for programming purposes. For the goals of this project, it was split into two phases. The first phase was base goals, and the second was the stretch goals. The base goals were things that had to be done for the project to be a success, and stretch goals were things that we would do if we had time. However, one of the base goals did get canceled because it is no longer used, which Zach will discuss in issues.
Thanks, Andy. We had several issues we encountered this semester while assembling our design. One big issue was that we were unable to communicate with our barometer because the data in and data outlines on the schematic got crossed between schematic pages. This was fixed by cutting the traces and rerouting the signal lines with enameled wire. Another issue we encountered was PWM signals not being accepted as a signal source by our firmware, as they're heavily deprecated and a dated communication method and better standards exist today. Not wanting to implement outdated features on the quadcopter, the decision was made to not focus on including this in the final design. We had several other minor issues with a component ordered not being the right size footprint and having to order our barometer component from Amazon as component suppliers were out of stock. And now I'll turn it over to Chris.
Hello, my name is Chris Somphounout. I'll be talking about the design summary portion of our drone copter. One of the main reasons why we chose the components as they are for our drone project was due to the high popularity of the components on other references that we had reference from, such as the STM32 due to its high processing speed, the barometer for its cheap cost, and the gyroscope, which acts as a master for a magnetometer for our drone. If you look at the bottom left, that's our which is the green board. It's our printed circuit board. It's almost completed. The only thing that's missing, I believe, it's the magnetometer. On the right, is our the red board is our development board, which we gave to the CSCE to program and to see if they can read data back from the barometer and gyroscope before we were to put them on the green circuit board.
Currently, where we're at with our project is we have our completed flight controller. We've reached all of our primary goals of this project. We're able to control the drone with a remote controller, and we're able to get sensor readings from the board. What's currently not working is the PWM signals, as stated in our issue earlier. Moving forward from here, we would continue with app development, allowing us to be able to control the drone from the phone app and be able to get sensor readings on the phone. This would be done using a host server that would be on the board. Overall, this project was a success as we're able to control the drone, maintain a hover, and have some stabilization, which all improves on the CC3D flight controller's design.